Hello again, it is Mrs. Trombley, and today we are going to review how to multiply and divide integers. And again, those are positive or negative whole numbers, including 0. And to start off, we're going to use a pattern to understand these rules. I find that when we memorize the rules, we don't remember them as long as we should. We only remember them for a short time. But if you discover and understand them, then you can know them for a lifetime. It sounds like a t-shirt or a poster, doesn't it? But it's the truth. Okay, so in looking at these tables, there are some of these problems that you'll already know, right? And these are this is one set of patterns we're going to look at and another set of patterns that we're going to look at. So on this half, I already know 2 times 2. You do too, right? 2 times 2 is 4, 1 times 2 is 2, 0 times 2 is 0, and then we start getting into some negative numbers, and maybe you're thinking, well, I don't remember. I learned a whole bunch of rules last year. I can't keep them straight. So hopefully we'll be able to keep them straight and understand what's going on here. Okay, so what I would like you to notice, first of all, is that all of these numbers are being multiplied by 2, right? And we're seeing that if I'm going down the line here, this is going down by 1 every single time, right? So 2, 1, 0, negative 1, negative 2, negative 3. This isn't random. This is a pattern. It's set up that way. In order to figure out these 3 values, I can use the pattern that's going on here because there's a pattern going on here. So if I'm going from 4 to 2 and 2 to 0, isn't this just going down by 2 every time, right? So if I'm going from 4 to 2 and then 2 to 0, this one should be 2 less than 0. 2 less than 0 would mean 0 minus 2, right? 2 less than 0. And you learned to keep, change, right? So 0 plus negative 2, that's negative 2. Now this next one should be 2 less than negative 2, meaning negative 2 minus 2. This shows 2 less than negative 2. When you keep, change that, negative 2 plus negative 2 gives you a negative 4. And 2 less than that would mean negative 4 minus 2. So negative 4 minus 2, or negative 4 plus negative 2, gives me negative 6. So these should all be correct based on our pattern, right? Now let's try another pattern. I promise I'm going somewhere with this. Just bear with me. And with this one, we see that this time, the first number, that's the one that's the same every single time. It's negative 3, and so on and so forth. And these numbers are going down by 1 every time. So let's pick out, are there any that we know? Well, I see negative 3 times 0. And I know that any number multiplied by 0, including negative numbers, is going to give me 0. So I'll fill that one out. The rest of these have a whole bunch of negative signs or positive signs. Some of them the same, some of them are different. So I'm going to leave those alone for now. Okay, so I'm going to use repeated addition to help us figure out some of these. And then we'll use a pattern as well. If you have negative 3 times 3, doesn't that mean that you have negative 3 times? Meaning a negative 3 plus another negative 3 plus another negative 3. Multiplication is just repeated addition. So this means the same thing as that. And we already learned how to add these, right? When you add the same sign, you add the digits. 3 plus 3 plus 3 is 9. And we keep the sign. And just picture 3 negative blocks, another 3 negative blocks, another 3 negative blocks. That's 9 negative blocks. Yep. Now look at the next one. This is negative 3 times 2. That means I have negative 3 twice. This means the same thing as negative 3 times 2. So negative 3 plus negative 3, that's negative 6. If you have negative 3 one time, that just means you have a negative 3. And now let's take a look at this pattern. Picture on a number line, if you're going from negative 6 to negative 9 to negative 3 to 0, I know these digits are decreasing, but the value is actually increasing, right? Because you're moving to the right by 3 on the number line. So to get this negative 6, we're really taking negative 9 plus 3. Negative 6 plus 3. Negative 3 plus 3. So then I'd want to take 0 plus 3 to get this next answer. And I'd want to take 3 plus 3 to get this next answer. And that kind of completes the pattern here. Now, what we want to pay attention to is the signs. Because as you look at all of these problems that involve negatives, nothing's changed about the multiplication. 1 times 2 is still 2. 2 times 2 is 4. 3 times 2 is 6. 3 times 2 is 6. 3 times 1 is 3. 3 times 3 is 9. Nothing's changed about the digit, but what we have to pay close attention to are our signs. And the first fill in the blank here says the product of two integers with the same sign. So that means 2 positives or 2 negatives. And let's look for all those that apply. So same sign, 2 times 2, those are both positive, both positive. Do you see any more where they're both positive? No. Now I want to look for when they're both negative, and that would be here and here. So when we're multiplying and the signs are the same, what do you notice about your answer? It's always positive. It's always going to be that way. The product of two integers with the same sign is positive. So I know when you add 2 negatives, you get a negative, but this isn't addition. It's multiplication. So same sign. So a negative times a negative is a positive times a positive is a positive. On the opposite end of that, the product of two integers with different signs, so let's look at all the ones where they're different. These have 2 different signs, 2 different signs, 2 different signs. Most of these do. I'm highlighting all of the ones that have different signs. And 0 isn't positive or negative, right? That's its own little property. We'll leave that alone for now. But what do you notice about all the ones highlighted in blue? What kind of answers do you have? Negative. And I know with addition that you take the sign of the greater digit, but that's not what's going on here, is it? And when you have the same digit with opposite signs, you don't get 0 for an answer. So multiplication and addition, they're not the same thing. The rules for them are different. So when you multiply, when you're finding the product of two integers with different signs, your answer is always going to be negative. No matter what, it doesn't matter which sign is greater or which number is greater. So same signs, 2 of the same sign positive, 2 different signs negative. And with these zeros, we're just using the multiplicative identity. Multiplicative identity, as I'm sure I've said in class 800 times. Whenever you multiply a number by 0, it's still always just going to be 0. Positive, negative, doesn't matter, always gets 0. So let's use our new little integer rules for multiplication to do a few practice problems. Feel free to try these 9 on your own and then press play and see if you got them right. Or just do it with me, that's fine. Maybe you see these 3 numbers down here and you're like, what? We never did that. Well, we will now. And the exponent stuff, don't worry about. Okay, so in multiplying integers, the way you multiply the numbers hasn't changed. So just look at the digits, 5 and 6. I'm multiplying them. 5 times 6 is still 30. Yep. And now I see I have a negative times a negative. So same signs, positive 30. Done. Here, a number next to parentheses, this means multiplication. Yep. And 3 times 4 is 12. And one of each means negative. Doesn't matter that the 4 is greater, and that's why we have a negative. It's not it. One of each means negative. 4 times 7 is 28. One of each means negative. It's okay that the 4 is lower than the 7. It's a negative answer because in multiplication, one of each means negative. I threw this one on here just for kicks so you understand that nothing has changed about this. 5 times 5 is still 25. And they're the same sign, so positive answer. A negative 7 multiplied by another negative 7. Common errors that people would say, oh, that's 0. Or that's negative 14. Don't add them. Multiplication. 7 times 7 is 49. A negative multiplied by another negative is a positive. Negative 4 times 0. Anything times 0 is 0. Please don't put a negative sign in front of the 0. It's not possible. You can't have negative nothing. You can just have 0. Maybe if you have nothing it is bad, it's negative, but you can't have negative 0. Alright, next I have a couple digits in here. And again, you can use those commutative and associative properties if you would like. And you can switch around the order that you multiply these. So I might do negative 3 times negative 4 first. But for this one, I'll just go from left to right. Okay? So I see I have 2 times negative 3. When you take 2 times negative 3, that's negative 6, right? And I still have this negative 4 left to multiply. Negative 6 times negative 4, that's a positive 24. So we talked about our rules, and our rules applied when we have one of each. Just because I have one of each here, I still have another one. It doesn't mean that this is going to be negative. It's the product of 2 integers with the same sign that's positive. So that would give you a positive 24. Next one here. This time, why not? I'll multiply these 2 first. because I can, because I like the associative property. Negative 2 multiplied by negative 1, that's a positive 2. Same signs, it's positive. I still need to multiply that negative 5 by the positive 2, so you'll get a negative 10. And I'm hoping that maybe you notice that, hey, if I have an odd number of negatives, I get a negative answer. But if I have an even number of negatives, I get a positive. Every 2 negatives in multiplication is going to give you a positive result. So if you have pairs of numbers, if you have an even number of negatives, you'll get a positive result. And odd, if it takes 2 negatives in multiplication to make a positive, if you have an odd, you're always going to have that one extra negative that makes the result negative. Here I see a 0 and it's multiplication, so I know my answer is 0. And again, it's not a negative 0. Maybe you went across and said, well, that's negative 66, and negative 66 times 0, well, positive times negative is a, 0's not positive, it's nothing. So just plain old 0, please. All right, so hopefully that's okay, and got that down. Let's do a little exponent review here. This part here, I found that people always have kind of a hard time understanding it. I think I did too back in the day when I learned this stuff. But there's a difference between negative 3 in parentheses squared and just negative 3 squared. They look so similar that it's hard to wrap our minds around it. But first off, I'm not going to say negative 3 in parentheses squared. The fancy way to say it is the quantity of negative 3 squared. Whenever something's in parentheses, you can fancy it up because I'm so fancy. I know, I've had that song in my head for a few days. 10 years from now, it won't be funny anymore, but right now, you're going to have that song stuck in your head too. Tomorrow at school, you'll be singing it, so I know that you watched the video. Yep. Anyway, the fancy way to say this is the quantity of whenever something's in parentheses. If I have the quantity of negative 3 squared, that means that I have negative 3 being multiplied twice. This is my base, this is my exponent. The exponent tells me how many of the base to multiply. So a negative 3 in parentheses squared means that you have a negative 3 multiplied by another negative 3. You don't have to put those parentheses around it. I did it just for fun. So when you multiply 2 negatives, you get a positive, right? This would be a positive 9. So these parentheses are kind of keeping the negative with the 3, and it's saying take this negative 3 twice. This next one, the base, is not in parentheses. Big number's the base, little number's the exponent. So you remember when we did absolute value, how, and you don't have to write this, I'll write this on a different sheet of paper over here, and you had something like this, the absolute value of negative 2, and there was a negative sign in front, and this meant the opposite of whatever that is. So for this, we'd end up getting a negative 2 because the absolute value of negative 2 is 2, and the opposite of that's negative 2. We're kind of going to use that here. This means the opposite of whatever 3 squared is. So ignore that right now and bring it at the end. The opposite of 3 squared means the opposite of 3 times 3. So in this one, I'm doing the 3 squared and taking the opposite of it. 3 times 3 is 9, and the opposite of 9 is negative 9. So 9 and negative 9 are very different from one another, especially someday when you have a checkbook and you're balancing them. If you mess up that negative sign, it's kind of a big deal. These are different. This means I want to repeatedly multiply a negative 3, and I'm putting parentheses around it to keep it that way. This means I'm going to do 3 squared first and then take the opposite of it. So just remember that the parentheses keep the negative with it. No parentheses means take the opposite of whatever you get. So now I have an exponent of a 3. This is the quantity of negative 2 cubed. That means I'm multiplying 3 negative 2's because the negative stays with the 2. So just going from left to right, negative 2 times negative 2 is 4. Those are done. And then 4 times that last negative 2 is a negative 8. So I'm going to get a negative result. Maybe you knew that already because you saw, oh, there's an odd number of negatives. That means negative result. Yep, that's what happens. All right, this is the opposite of whatever 2 to the 3rd power is. So that means the opposite of 2 times 2 times 2. So here, my base stays positive as I'm multiplying it, and at the end, I take the opposite of whatever I get. So 2 times 2 is 4, and 4 times 2 is 8, and the opposite of 8 is a negative 8. So just be very careful. Those parentheses make a difference. It's going to be a big deal to us in later chapters, so it's really good to have this kind of understanding built for you now. So lock it in there. All right, turn your page, and this is kind of like addition and subtraction, where the addition took a little bit longer, but the subtraction didn't because we just learned how to use those same rules. It's the same with dividing integers. You can use the fact that multiplication and division are inverses to help you understand these rules for division. So here's how we're going to do it. We're going to look at our kind of little families like you did back in elementary school. You know that 4 times 3 is 12, right? And if we're looking at this as division's the inverse, the opposite of multiplication, this means that 12 divided by 3 is 4, or 12 divided by 4 is 3, right? We know that that's the truth, and we're going to use that to help us discover our division rules. So the first thing I ask you to do is rewrite each multiplication problem as its 2 division problems, because this is going to help us understand what we're doing now, I promise. So if we know that 6 times 3 is 18, that means that 18, if we're working backwards, 18 divided by 3 is going to be 6, or 18 divided by 6 is going to be 3, right? And notice all those digits stayed the same. We didn't change any signs. Take a look at this next one. We know that when you multiply 2 negatives, you get a positive. So this statement is true. And if we use the same property that we just did, this means that 18 divided by negative 3 should give me a negative 6 because we don't change any signs. And 18 divided by negative 6 should give me a negative 3. Right? Take a look at the next one. We know that when you multiply and you have one of each, you get a negative result. So a negative 6 times 3 is a negative 18. We know this to be true. That means that negative 18 divided by 3 should be a negative 6 because I'm not changing any signs. And a negative 18 divided by negative 6 should give me a positive 3. This is true. And one last problem here. We know that the signs don't matter. So when you take 6 times negative 3, not the signs don't matter. Whichever digit's higher doesn't matter. 6 times 3 is 18. And when you have one of each, it's automatic negative. It doesn't matter that 6 is greater and it's positive. That's only with addition. So this means that negative 18 divided by a negative 3 is a positive 6 because I'm not changing any digits. And negative 18 divided by a positive 6 will give me a negative 3. So we're going to use these patterns to help us fill in the blank. The first blank says, the quotient of 2 integers with the same sign is. So let's look for all the quotients where we have the same signs. Here, those are both positive, both positive. Here I have one of each, one of each. Here I have 2 negatives, so the signs are the same there. 2 negatives, so the signs are the same there. What do you notice about when you divide 2 numbers with the same sign? 6, 3, 3, 6. All those are positive numbers, aren't they? So the quotient of 2 integers with the same sign is positive. Now take a look at the flip side of that. The quotient of 2 integers with different signs. So if we look at this, these are 2 different signs. I have one positive and one negative. Here I have one positive, one negative. Here I have one of each. Here I have one of each. What do you notice about every single one of those green answers? Negative, 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 negative. It doesn't matter which one's greater. In these problems here, the 18 is greater than the negative here. The positives are greater than the negative, but I still have a negative answer. Right? It doesn't make a difference. No matter what, if you have 2 different signs when you're dividing, it's always going to be negative. So the rules for multiplication and division are the same. Isn't that wonderful? So multiplication and division have the same rules. That means we just need to know one set of rules. And hopefully we have an understanding so we're not just memorizing it, we get it. All right, so let's try a few now. Find each quotient. We know that means the result of a division problem. And we've seen in all of these, to get the digit, nothing's changed. You divide like normally, right? Divide like normal. 2 of the same signs means my result is positive. 2 different signs, the result's negative. So let's try it. 14 divided by 2 is 7. Same signs means it's positive. 40 divided by 8 is 5. Same signs means positive. 0 divided by negative 6. 0 divided by anything is 0, right? Is it a negative 0? Because you might think, oh, this doesn't have a negative sign on it, so those are different signs. No, 0 is 0. Do not write negative 0. And then this is where I usually get the question, will you mark it wrong? If I have to, I will. I'll feel really bad about it. But there's no such thing as negative 0. So don't write it. Don't write an answer that there's no such thing as. All right, these are fractions. Fractions are just little division problems. This means negative 49 divided by a positive 7. 49 divided by 7 is 7. When you have one of each, that means it's negative. 21 divided by negative 3. That's what this means. 21 divided by 3 is 7. One of each, negative. So notice, in this one, the greater digit's negative. In this one, the greater digit's positive. Both answers are negative because in multiplication and division, it doesn't matter which is greater. One of each means automatic negative. This one looks a little bit weird because there's a negative sign in the middle. Just look at this as the opposite of, okay? So the opposite of 15 divided by 5. What's 15 divided by 5? It's 3, and the opposite of 3 is negative 3. You could also look at this as a negative 15 over a positive 5, or a positive 15 over a negative 5. When you see that negative sign in the middle, it's allowed to go with either the top or the bottom. Because if I put it with the top, isn't negative 15 divided by 5 negative 3? And if you put it with the bottom, isn't 15 divided by negative 5 also negative 3? Yes, so think about slope when you have negative slopes. And if you haven't covered that yet, we'll get there soon. And it'll all tie back to this. This does not mean that the 15 and the 5 are negative. Because if you divided two negatives, wouldn't you get a positive result? Yep. If I wanted them both to be negative, I would put a negative sign in front of both of them. So just know that all of those things mean the same exact thing. Last one, I have the opposite of 9 divided by 0. Now we know that 0 divided by a number is 0. But if you try to divide by 0, try it in your calculator. It's going to come up as error. It's going to tell you can't do it. That's because you can't divide something by nothing. If you're dividing by nothing, you're not doing anything, right? So the answer to this is actually called undefined. There's no definition for it, meaning there's no answer for it. You cannot divide by 0. It's the 11th commandment. Thou shalt not divide by 0. You can write that down if you like. But 0 divided by a number is different than a number being divided by 0. So if you see that 0 comes second, not first, or that 0 is in the denominator, that means it's undefined. There's not an answer. Don't write 0. If you do want to write a 0, put a slash through it like that, so we know it means there's not an answer, it's undefined. That's enough for today. See you tomorrow.